This is the last lecture for Unit 2, and so far we've discussed across multiple lectures more detailed information about various research designs. So again, how do we go about creating or building the research studies and things that are important within each one of those designs when we're trying to test research questions overall. There's still one more piece of information that it is important for us to understand, and that has to do with who are going to be our participants. So again, so far we focus a lot about what the participants are going to be doing, but we haven't discussed much who the participant is going to be and how do we make the decisions on who to invite to participate in our research studies. So today we're going to talk about a few introductory concepts, and then we're going to move on into discussing various sampling techniques. First, it's important for us to understand the difference between a population and a sample. A population is going to be any group of people or objects or events that meet the characteristics of what the researcher is interested in learning about. So for instance, if your research question has to do with first generation Hispanic students, then your population has to meet those characteristics. It has to be first generation people who are Hispanics. Or if your research question has to do with people that are going through a breakup, then your population has to meet those characteristics, which is, again, they are going through a breakup. And the other thing to consider about populations is that population is going to be every single individual that meets that criteria. So again, if you are interested in first generation Hispanics, every single first generation Hispanics that exist is going to be part of your population. Now, considering that and that number will probably be humongous, you can see that it's oftentimes impossible that we will be able to find every single one of those individuals and have them be part of our study. Why? Because again, many times there's not even a way to locate every single individual that is going to meet the characteristics of the psychological phenomena that you're interested in. Or even if you could, it's going to take a lot of time, a lot of effort. So it's a lot of resources that typically researchers do not have. So although if you wanted to learn about first generation Hispanic students, ideally it would be best if we truly find every single person that meets this criteria and have them be part of a study. It's oftentimes impossible. So the second best thing we can do is get a sample. This is going to be a group of individuals that are chosen from the population to represent it in our study. So similar to when you go to an ice cream place and you want to try out one of the flavors, you ask for a sample. The sample is going to give you an idea of what the flavor is going to taste like, and then you can make decisions on whether you want to purchase it or not. In a very similar way, we use samples in research studies to kind of make assumptions about the populations or make predictions about the populations, and later on some decisions depending on how strong how strong the evidence is. So again, population is going to represent absolutely everyone that meets the criteria of the psychological phenomena that you're interested in, and that's going to be dependent on the research question the psychologist has. The sample is going to be a portion of that group of people that are also meeting the characteristics, but it's not going to be everyone who meets the characteristics. It's only going to be a few of them. Now, in psychological research, our samples are more commonly college students, or now with the advancements of technology, we have a lot of online samples as well. Now, there are advantages and disadvantages to both. Towards the end of today's lecture, we'll discuss a little bit more on online samples. Now, before I talk about sampling error, one thing that I want to point out is towards this corner, I've kind of included a visual that, at least to me, is helpful when thinking about populations and samples, and something that I'll use throughout today to kind of show you the various sampling techniques and how those sampling techniques are working. Now, I think of this as a little olive. And you see most of the surface is in a green color. Everything inside this green circle is representing your entire population. So again, this is absolutely everyone that you're interested in. And the little like seed opening in orangey color is representing the sample. So we're only scooping a little bit of a part of the population. And again, that's what we're going to use to speak of the population in general. So I can keep that visual in mind as we discuss some of the things today, so that hopefully it makes a little bit more sense when we're speaking of the population and we're sampling from the population. Now, before I move on to the next thing, it's also important that we understand what sampling error is. Again, I already mentioned the notion that we use samples to say something about the population. So again, they're closely related to each other because we're going to be using the samples to make predictions or descriptions of the population in general. But one of the things that we're going to learn, especially as we move on now closer to the statistical concepts and ideas in this course, we're going to see that depending on who your sample is, the findings might potentially change. Why? Because every single time that you're taking a sample, you're scooping potentially different people, and we're going to see a little bit of that today, mostly on a different lecture, but a little bit of that today. But you're scooping different people, and those people come with individual differences, right? Something we already discussed on some of our previous lectures, why it's important, the kind of research design we use, and how manipulations are presented to participants because of those individual differences. But again, what we're trying to do is use the sample to speak of the population. But again, depending on who participated in your study, this sample might be more accurate or less accurate in actually describing the population. And sampling error is going to be a measure of this. It's going to see what is the difference between the observations in the population, so what is actually true in the entire population, versus the sample that we're using to make predictions of this population. So the greater the difference between the population and the sample, the lower the validity of our results, which is indicating that the accuracy of our results is most likely going to be low. And obviously, if we're not accurate about describing the population through the usage of this sample, then we cannot trust these findings as much. So again, sampling error is going to be a way of us speaking of how well the sample that we've selected is actually representing the population that we're interested in. And here we have another visual representation of this. Again, the bigger circle is going to be the population, and this is going to be every single individual that meets the characteristics of the psychological phenomena that you're interested in. The sample is going to be people that were chosen out of this population, that we're actually going to be the ones that we're going to answer questions to and have all these different observations so that we can later on make predictions about the population. Here you have some practice problems that you can do to practice identifying the population versus the sample. Pause the video here. On the next slide, you're going to have some of the answers for this. Again, remember, the population is every single individual that is going to meet the criteria or the characteristics of the psychological phenomena you're interested in. The sample is going to be a few of those that you're sampling to be able to say something about the population later on. And here you have those answers. This is going to detail what the population actually was and what the sample was from each one of these scenarios. So now that we have an understanding between what is the difference of a population and a sample, we're going to move on to something slightly different, but closely related to these two concepts, and that is going to be probability. Now, probability is something that you're probably familiar with. This is something that is taught back in high school. So we're going to go very quickly through this and how to calculate probabilities, but then I'm going to transition you very quickly into how does this get reflected into human behavior. And here we have an example of a coin toss. So when you toss a coin, you can either get heads or you can get tail. We have two possible outcomes, and one of them are typically of interest, right? So when you toss a coin and you're, I don't know, doing a bet or trying to decide who's going to do what, typically someone's going to say heads, right? So if it lands on heads, that person's going to do something. If it lands on tail, the other person's going to do, again, whatever task is that you might be avoiding. Each person has a 50% chance of being the one to be selected to do or not do something, again, depending on what it is that you're trying to decide. And that is because the odds of getting the outcome that they've decided for, such as head or tail, in comparison to the total number of outcomes that are possible, which in this case are 2, the odds are 50% because you have 1 out of 2 chances that this is going to be either heads or tail. Now again, we can do something very similar with human behavior, but we're going to see that a little bit later. Another quick reminder about probability is that we can test the probability of multiple events happening in a very specific order. So the one that we discussed before is simply one event. You toss a coin and you either see if it lands on heads or tails. And we can tell the probability of that one event. But if we also wanted to say what is the probability of a specific sequence of events happening, we could also do that. So here, for instance, we are trying to find the probability of getting 3 heads in 3 coin tosses. So we're looking for, you toss the coin once, it lands on head. You toss the coin twice, or for a second time, excuse me, and it lands on head, and then you toss the coin again for a third time and it lands on head. And again, we want to know what are the odds that when we do that 3 times, every single one of those times we're going to get heads as an outcome. And there are various different combinations in which this could possibly happen, or a possible outcomes when we are considering 3 multiple coin toss. So here we see those possible outcomes. We have heads, heads, head, tails, head, 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 tails, head, and so on. I'm not going to continue because it's pretty much, I think you got the point, the gist. Now, again, we were interested in learning how many, or what are the odds, the probability of getting 3 heads back to back. In this case, we can see that there's only one possible time that this is going to be the case. That is our outcome of interest. But in reality, we have a possible outcome. So when we're trying to get the probability, we're going to see that it's going to be 1 out of 8 likelihood that, again, we're going to get the outcome we're interested in. So we're going to divide 1 by 8, which is going to give us 0.125 or 12.5%, which is the equivalent percentage to the decimal we see here. We could also have left this in a ratio format, so 1 out of 8, and all of these answers are equivalent to each other. They're representing the same probability. They're just being represented either by a ratio, a decimal, or a percentage. Either one of those, again, is correct because they're representing the same level of probability. So in general, for you to calculate probability, and I have this little kind of formula here down for you as a reminder, probably a good idea to write this somewhere else as you study and then you do some of your homework assignments and then later on your exam. But probability is going to be on the top, the result of interest. So again, what are you trying to find? Divided by the total number of possible outcomes. So this is always going to be how you arrange this information. Here's a quick example for this. Imagine that we roll one standard 6-sided die 10 times. After rolling the die 10 times, we write down each result. So here we have 2, 5, 1, 6, 3, 2, 4, 6, 1, 5. And here are 2 questions that are being asked for you to do using this particular data set. The first one is to calculate what is the probability of each possible outcome. Well, for a fair 6-sided die, each number has an equal chance of occurring because each side is going to represent one individual outcome. 1, 2, 3, 4, 5, 6. So the probability of each outcome is going to be 1 out of 6 because every time you roll the die is going to be an odds of 1 out of 6. The number can only come up once in each individual event. So this is similar to when we flip the coin. It's only one event that we're considering, 2 potential outcomes. In this case, only one event for each possible outcome because we have numbers going 1 to 6. And the total possible outcomes are 6 because, again, we have numbers 1 to 6 since we're using a fair 6-sided die. So that's kind of a simple type of probability. The next question says, what is the probability of an outcome being an even number? So now we're considering multiple events at a time. And the question itself is telling us what kind of event we're interested in. In this case, we want to know what are the odds of getting an even number. So again, we're working with this fair 6-sided die, and the even numbers on the die are going to be 2, 4, and 6. So they're going to be 3 even outcomes out of 6 total possible outcomes. So the probability of rolling an even number is going to be 3 out of 6, or 1 out of 2, which is just a reduced fraction from 3 out of 6, so it's equivalent to that, or 50%, which again is the percentage that is equivalent to 1/2 or 3/6. All of these numbers mean exactly the same thing. So just as a reminder, when you're calculating probability, you have to think about 2 pieces of information. The first one is what is your result of interest and how many times is your result of interest showing up in your data set. And you're going to divide that by the total number of outcomes. So again, what are the total possible number of outcomes? Or when we're dealing with human behavior, what are the number of observations that we have in a data set? We can also calculate the probability of human behavior. And that's exactly what we do It does change slightly depending on how we're measuring the behavior, which you're going to see in one of the slides. But in this case, in this particular slide, you're going to be seeing one human behavior, which is some form of aggression, and you're going to see two potential outcomes. You're either going to punch someone or you're not going to punch someone. And here again, you see this being represented as somewhat equally to tossing a coin. Again, the coin is going to have two potential outcomes, head or tail. So in the case of tossing a coin, if you land on head, then you're going to say that was 50% chance of landing in head. Whereas in the case of aggression, based on how we're measuring it here, either you punch or not punch, there's a 50% chance that the person or the individual that we are observing is going to punch or not punch. And again, this is pretty much what we do with human behavior. We calculate the probabilities of something happening. So probability can be applied to human behavior. And the behavior that we observe from that one individual is the outcome of the toss. So again, here I have 5 different individuals. In red, you can see the action or the outcome of this toss, whether they punched or they didn't punch. And there are 2 things that I want to emphasize about this. The first one is that our outcomes are going to be partly determined by the scale of measurement. So again, what type of scale are you using to measure this particular behavior? Well, in the case of the example that we started with, we have aggression being measured as whether you actually punch or didn't punch the person. Whereas on this other side, we have a 7-point Likert scale that has 7 different outcomes because you can score 1, 2, 3, 4, 5, 6, or 7. And this is most likely going to be us asking the participants, how likely are you to punch this person? And they can decide, again, either one of these responses. Number 1 would be not at all likely to punch, whereas 7 is extremely likely to punch. So maybe those ends are going to represent the punch, no punch of the other type of scale that we used previously, but we can see that there's more variation in this type of behavior because they can also say that they are not likely to punch the person, but they kind of wanted to if they pick a 3, right? So it's kind of like it gives us more nuance in seeing what the behavior actually is depending on what scale of measurement we're using. Now, for simplicity purposes, I will continue using our scale of punch, no punch, so we have more of a categorical type of behavior here. Again, just to explain the different sampling techniques. But I want you to keep in mind that depending on the scale of measurement, the outcomes for the same behavior can be different because in this case, when it's categorical, it only has 2 possible outcomes, but when it is ordinal, it's going to have up to 7 outcomes. The other thing that I want to emphasize again is the importance of realizing that who our participants are matters when it comes to describing a population. And here we have a very simple example of this. Again, here is the population of interest that I have. So let's say that all of these people meet the criteria that I'm interested in, and I've measured their aggression or, again, their likelihood of punching, not punching. So my population is going to be represented by everything that is outside of the square right now. The square is representing kind of like a zoomed in portion of my population. So I randomly selected 3 people to be my sample, and then I'm going to calculate the overall average of my sample so that I can make inferences or predictions about the population. So based on the people that I have here, so I have 3 individuals. Out of those 3 individuals, 2 of them are going to punch based again on the measurements we have here inside the square. If that is the case, we're going to have about 2 out of 3 people that are going to punch another person based on whatever it is that we are measuring. Maybe we're asking them, would you punch someone after they have insulted you? Or 66.67% of people would punch. This is a high probability of punching another person after being insulted. But let's consider what would have happened if we had selected a different set of individuals from the same population. So again, both of these samples belong to the same population. We're just looking at different individuals that were selected. And here, if we had selected these 3 individuals, now we have 1 punch and 2 non-punches. So this is giving us the same probability as in we have 2 out of 3, but in this case, 2 out of 3 is representing people who are not going to punch. Or if we're focusing specifically on punching, this is 1 out of 3 people who would punch. So the odds now went from having a sample that has 66.67% likelihood of punching people in the population. It was representing the population, which probably we would say this population is quite aggressive, versus having 1 person punching another individual, which is representing 33.33%. Again, this would indicate that the population overall, assuming that we're using the sample to speak of the population, is less aggressive than sample 1. So again, I want to emphasize that depending on who your participants are, your findings might be very different. So now we're getting into sampling techniques or specific ways in which we select participants to be part of our studies. Sampling from a population is a 2-step process. The first one is that we need to select individuals from the population for the sample. And then the second one is that we're going to observe the behaviors that you are interested in. So we're going to be collecting data from the individuals in that specific sample that we've created. So right now, again, we're going to focus more heavily on how do we select individuals from the population for the sample. And again, I want to emphasize that the way a researcher samples from a population for their study can influence the amount of sampling error present in their data. Because as we saw on that one example, we went from having a sample describe the population as 66.6% aggressive, whereas another sample was describing the population as 33.3% aggressive, right? So obviously both of those cannot be correct. So both of those are probably having some kind of discrepancy between the real population. So again, who our sample is matters because this is going to influence the amount of sampling error that is going to be present in our data. And again, sampling error is simply the difference between the population mean minus the sample mean. And the main goal is for us to achieve a balance between the sampling error and a representative sample. So we want to have a sample that is similar in characteristics to the population overall. But again, it gets really, really hard as researchers to get a representative sample because typically it means more time and resources to be able to do that. So whereas we will do our very best to have a representative sample so that we can have a lower sampling error, there might be, again, some compromises to make. Overall, there are 2 types of samples. We have probability samples, which are samples that are chosen so that individuals are chosen with a specific probability. And then we have convenience or purposive samples, which are samples chosen such that the probability of an individual being chosen cannot be determined. Convenient samples are easier to obtain, but they're going to have lower internal validity. They're going to have higher sampling error, and they're going to make it harder to test hypotheses. So again, probability samples, because of these reasons, are going to be better than convenience samples. So again, probability samples will be better than convenience samples. Because, and this is a good way to think about this too, probability samples are pretty much representing that the researcher went the extra mile to pick a good sample to test the research question. Convenient sample, it's not that it is a bad researcher, it's just that they went for what was available to them, what was convenient to them. So they didn't put any extra effort in making sure that the sample was the best sample for the research question and truly represented the population. And again, if we want to have accurate findings, meaning lower sampling error, then we want to have a sample that is as close as possible to the population, because we're going to be using the sample to make predictions or assumptions about the population. We have multiple types of probability samples. Again, all of these are going to represent the researcher doing something extra to get the best possible sample. But within each one of these probability samples, we're going to have some that are better than others. And we're going to discuss each of those in detail. We're going to start with simple random sample. This is a sample chosen randomly from the population such that each individual has an equal chance of being selected. So for instance, students are chosen randomly from a list of all students at a university. The advantages is that it's going to reduce sampling error by choosing from all members of the population to best represent the population. But the disadvantages is that it's difficult to ensure that each member of a large population can be chosen. Again, depending on what your research question is, what characteristics your population has to meet, that population can be 5 individuals, that population can be 5 trillion people, if possible. So how would you manage to do that with 5 trillion people? That would be much more complicated. One of the things about simple random samples is that they give every single person who fits the characteristics of the population an opportunity to participate. So if we were to think of sampling as terms of a raffle, we would see that every single person in the population would get one ticket that is going to go into this urn that we're going to be mixing up, and we're randomly going to pick 3 winners. And those 3 winners are going to be our sample. Now, of course, the actual number of quote-unquote winners is going to change per study, but right now we're just working with 3 tickets since we have a very small population here. So here again, we have this like olive that I was talking about. The green area, again, as a reminder, is your entire population. So all that area is the population itself. And the sample, again, is the little scoop that we grab from the population. And we're going to be looking at that sample to make inferences about the population. So I've kind of enlarged this olive that we're working with. And again, we can see that everything in the green area, we have 10 participants or 10 potential people that meet the criteria for a population. So again, if this is first generation Hispanics, this means that everyone inside this green area is going to be first generation and Hispanic. But here we're still working with aggression, and we have 10 different people. Then in an orangey kind of color, you can see that 3 individuals have been quote unquote selected. And again, those that are circled by this orangey color are going to represent our sample. So we're going to use them and the observations of this behavior specifically from them to say something about the population. But again, how do we select these people? If it's simple random sample, again, we give each one of these 10 different individuals a ticket that again is going to be spin in this urn, and we're going to randomly pick 3 of them, and those are going to become our sample. But one of the very, very distinguishing things about simple random sample is that everyone has an equal chance of being selected. Cluster sample is another type of probability sample. This is a sample that's chosen randomly from clusters identified in the population. An example of this is doctors who work at a hospital are chosen for a sample by identifying all hospitals in different areas of the United States and then randomly choosing 10 hospitals in each area of the United States to sample from. The advantages is that it makes it easier to choose members randomly from smaller clusters to better represent the population, but the disadvantages is that it can ignore segments of the population that are not in the cluster chosen for the sample. Here we have a map of San Antonio, and we can see that this San Antonio area has been split into 10 smaller areas, and each one of the areas has 2 clusters that are representing the region. So in a cluster sample, again, we have these clusters, and we're going to have each cluster have 1 ticket. And out of each region, we're going to be selecting a ticket to represent that specific region. Now, depending on which cluster gets selected, that's going to be the cluster where we're going to survey people. So again, if cluster 10 has 2 clusters, or region 10 has 2 clusters, which it does because every region has it, and cluster 2 is selected, then everyone within that cluster would be the ones that get randomly selected to be part of the study. But one of the disadvantages that we discussed that I wanted to emphasize mostly here is that you can see there are going to be some regions that are not even remotely represented by the clusters that are going into this kind of raffle to be selected to be part of the study. So for instance, if we look at region 3, we can see that both of the clusters that are intended to represent region 3 are kind of to the side of that region towards the end, kind of like below region 2, but there is no cluster at all that is representing that area between 4 and 3. So again, there might be some areas that are not represented by these clusters, and if we're only choosing people that are within the selected clusters, then we're missing out on really learning about the region itself. This is the last type of probability sample that we're going to discuss, and is stratified random sample. It's a sample chosen from the population such that the proportion of individuals with a particular characteristic is equivalent in the population and sample. This means that we're matching the population demographics in our sample so that our sample can best represent the population. So for instance here, the example says, registered voters are randomly selected from lists of Democrats and Republicans to equal the proportion of registered Democrats and Republicans in the United States. So again, if they are 60% Republicans in the nation and 40% Democrats in the nation, our sample should replicate those characteristics and have 60% of people in the sample be Republicans and 40% of people in our sample be Democrats. Now, the advantages of this is that it's going to reduce any kind of biases that are related to these characteristics, but the disadvantages is that It's similar to those of the simple random sampling. We want to give everyone that fits the population an equal chance of participating, but it's hard to really give everyone an equal chance when we're dealing with a really large population. Here we have a visual representation of how this would work. We have the same 10 individuals that we have been working with, but now we can see demographic information for each of them, specifically their gender, whether they're a female or male. Now here, again, remember that everything within the green area is representing the entire population, and what is in the orangey circle is your sample. Now, based on the entire population, we can see that the proportion of males to females, or excuse me, of females to males is going to be 3 out of 10. So out of this population, 30% of them are female. So when we are building up our sample, we need to closely match that proportion. And in our sample, we should also have 30% of those being female. So what you would need to do in a situation like this is that you're going to have two separate urns based on the characteristic that you're trying to match, in this case, gender, because stratified random sample also gives everyone an equal chance of participating, irrespective of also matching the demographic characteristics. So in the case of females, here we have 3 females. They will each get a ticket that will go into the female urn. And then for males, we have 7 males. Each one of them will be given a ticket that is going to go into the male urn. So again, everyone is still having an equal chance of participating because everyone's getting a raffle ticket. The thing is that we're going to pick winners separately. We're going to pick a winner for females and 2 winners for males so that we can match the proportions of the population. So I will spin this urn and I will randomly pick 1 ticket for females. And then I will spin the urn for males and I will randomly pick 2 tickets for males. And those 3 individuals will become my sample. And you will see that this proportion is similar to that of the population, but in a smaller scale. Why? Because again, typically the population is really large. It takes a lot of time and resources to do, but the sample is much doable. But we're still working with a sample where everyone was randomly chosen and it's matching the population in demographic characteristics. So now we're moving on to convenience samples. And again, probability samples in general are better than convenience samples because the researcher is going the extra mile to make sure that those samples are, to an extent, the best possible samples for the research question. Convenience samples are based on convenience. So we're going to get what is the easiest for us to get. And the first type of convenience sample that we're going to discuss is volunteer sample. This is a sample that is chosen from the population such that available individuals are chosen based on who volunteers to participate. So again, it's based on who wants to be part of the study. Here we have an example. A group of students are recruited based on who scanned a QR code that was posted on the bulletin board. The advantages is that they are easier to obtain the probability samples, but the disadvantages is that they may not represent the population properly, especially because of selection bias, since random sampling is not used. So again, whoever wants to participate in the study is going to be our participants. And selection bias is very important to consider because let's say that I'm doing a study on human sexuality, and again, I've posted this all over campus, and people who scan this QR code volunteer to be part of my study. Well, it's more likely that the people who decided to participate in the study have positive attitudes about sexuality in general, because those that don't have positive attitudes about sexuality will probably be too shy to participate in those studies. So this selection bias influences our results because we are not going to be descriptive of everyone in the population and human sexuality, whatever aspect of human sexuality that we're interested in. We're going to be describing those who have positive attitudes about human sexuality. So it's important to keep that in mind and how it's going to influence your results potentially. So here we have a visual representation of this. Again, this is a first come, first serve kind of basis. So our sample is going to be whoever decides to participate. In this case, is going to be the first 3 individuals who see our QR code, scan it, and complete our survey. Our second and last convenient sample is quota sample, and this is a sample that is chosen from the population such that available individuals are chosen with equivalent proportions of individuals for a specific characteristic in the population and sample. So this is doing something very similar to the stratify random sampling, but it's not exactly the same because both of them are going to try to match the proportions or demographics of the population, but quota sample is still going to do so in a first come first serve kind of basis, whereas the simple random sampling is going to do so by giving everyone an equal chance. And again, that is very important because giving everyone an equal chance means that you're randomly sampling individuals, which gets rid of that selection bias. Here we have an example. 70% of students at TAMUSA are females and 30% are males. Out of a sample of 100 students, 70 must be female and 30 must be males. All students are recruited from the cafeteria. Advantages, again, these are much easier to obtain than probability samples while accounting for population characteristics. So again, it is better than volunteer sample. But when it comes to any other probability sample, is not necessarily the best. Disadvantages, again, is it may not properly represent the population because we're only getting the first people that we run across, and they're still potentially impacted by selection bias because there's no random sampling. Once again, here we have a visual representation of this. Again, quota sample, we will try to match the population characteristics. So again, if the proportion of females to males in the population is 3 out of 10, or 30% of the population are female, our sample should closely match that proportion as well, where the proportion of females in the selected sample is 1 out of 3, or approximately 30%. But again, in a quota sample, we're still doing this in a first come, first serve basis. So it is going to be the first female. So we're not going to do any kind of raffle. It's just whichever female we see first, that's going to be our participant. And whichever 2 males we see first, they're going to be our first participant. So those are the different ways in which we can select individuals to create our samples that will represent our population. Now, again, that was step 1, and step 2 is going to involve actually observing the behavioral interest in each one of these individuals and create a data set that is going to include all the observations. So again, the main idea of us collecting samples is that we're going to try to make predictions and assumptions about the population using a smaller number of people because surveying or making observations of the entire population is not possible. Again, there's too many people, it would take too many time and resources that oftentimes researchers do not have. But sampling error can be minimized. And specifically, the size of the sample is going to matter. Our sampling error is going to be smaller if the sample is large enough that is representative of the population. So again, the more people we get from the population, the more likely it is that we're going to be accurate in speaking of the population. But it is small enough that it is possible or feasible for us to actually recruit those individuals and observe them. Another thing that is going to be important is going to be variability, which is the spread of scores in a distribution. And this is something we're going to learn about in more detail later on. But one of the things that you need to know right now is that the more variability there is in the observations that we're making among people, the lower reliability we're likely to have. And sample size and sample variability are both going to be very important when we are calculating the sampling error in our data set. Researchers conduct multiple studies and collect multiple samples from a population. So similar to what I mentioned in how we started this conversation is that depending on what your sample is, you might get different results that say something differently about the population. Now, this is in part why we never say as researchers that we have proved a hypothesis, because again, with one sample we might have proved our hypotheses, but with another sample this may not show the findings that are proving our hypotheses. So instead we said we found support that this is the case. But again, because they are the odds, and the odds are big, that across multiple samples there are going to be differences, we never say that we prove anything. Now, when we put all the different samples that have tested the same population and the same research question, we're going to create a distribution of sample means. And we're going to talk a lot more in detail about this distribution and what it represents and how to read it. But for now, again, know that typically when we have a research question, we test it more than once. And we test it with multiple samples. And the most accurate answer, or the most accurate prediction that we can make about a population is going to be by taking all of those into consideration and averaging the observations across multiple of these samples. I mentioned that probability samples are better than convenience samples, and among probability samples that the stratify random sample is the best and would be the gold standard if we could all do it. So you might be asking, if that is the case and you all know that that is the best type of sample, why do most psychologists use convenience samples? Again, mostly that is because we just don't have the time and resources to do something more extensive than that. So there are a few things that we consider when we are deciding when to recruit participants, how many to recruit participants, and so on. The first one again is going to be how many to recruit. And there are very specific statistical formulas for this. We have to actually do some statistics for us to decide how many people we need, because you sometimes need a very specific amount of people to properly be able to test a research question. How you're going to recruit them? Are you going to recruit them in person? Are you going to recruit them online? Where are you going to recruit them? Are there going to be any incentives? Very rarely will people want to participate in research studies out of the kindness of their heart. Typically, it's going to be in exchange of something like course credit or money or access to a treatment, depending on the research question. And then what study design are you going to use? Because depending on the study design, it's also going to influence how many participants you need, how and where you recruit them, and the type of incentives that you give. And the last thing that we'll consider about our samples are internet samples specifically. And again, with technological advances, it is much easier for us now to be able to reach people that are not even close to us, so that we can ask them about things that we're interested in. So again, an internet sample is going to be a sample that is chosen from the population by recruiting specifically on the internet. Now, oftentimes, these participants are paid a small amount of money for completing these research studies and surveys. And there are multiple platforms that do this. We have MTurk, we have Prolific, and we have Qualtrics. Now, researchers can opt to pay more to recruit participants with specific characteristics. So again, if your research question is asking for people who smoke, then you can pay a little bit more to these platforms to find people that smoke. So they are, through these platforms, you're saving a lot of effort because they're doing the work for you in identifying the people that have the specific characteristics that you want your population to have, but again, it's going to cost you money. So it has been very helpful in so many ways because again, we can reach our target population much faster, but you need money to do this. And especially if you are a small university, this is often not going to be the case. Advantages is that, again, you can get larger, more diverse samples. There are fewer opportunities for bias due to the experimenter interaction with participants. So again, typically, all of these studies are done over the internet, so there's no much interaction between us as researchers and the participants. So there are less concerns about experimental bias, for instance. There are fewer constraints on the time and location of data collection. So when you have studies in person, it typically is going to be based on the availability of the researcher. So if I teach all Mondays and all Wednesdays, then maybe I can only run participants on Tuesdays and Thursdays. But then that means, for instance, in this case, that I'm missing out on all the participants or all the students. Let's say I'm recruiting students who take classes on Mondays and Wednesdays, right? And I'm only able to see the people that are not taking classes on Tuesdays and Thursdays and so on, right? So there are, again, some biases that are introduced when you do that kind of in-person collection, when online that is not necessarily the case because these are self-directed studies for the most part, so participants can complete the study at 2 in the morning on a Sunday if they wanted to. It takes less time to collect data because, again, multiple people can be taking the study at the same time versus if it's in person and you only have one experimenter, then you can only see one person at a time. And then again, fewer researchers are needed to supervise the studies, and there is more anonymity over the internet, right? I don't even have to see your face, or I will never potentially see your face. The disadvantages is that they are a group of people that lack internet access. So for instance, if you were interested again in low-income populations, most likely low-income populations are going to lack internet access. So you won't be able to access them. You can monitor or guide participants. So if the participant had any questions about the procedures, they have no one to ask, or if they do have people to ask, because oftentimes we'll provide our contact information, it's not guaranteed they're going to get a quick response. Again, if they're doing the study at 2 in the morning on a Sunday, I'm not going to be looking at my email at 2 in the morning on a Sunday. Or maybe they're just not paying attention. They're just like responding without like putting their focus 100%, and I don't get to see that as a researcher. And we cannot control how many times a study is completed. I mean, we can put limits within our internal surveys, but if the participant wanted to make 3 different accounts and take the study 3 different times so that they can get money 3 separate times, there's no way for me to stop that from happening. Whereas if this were in person and I've seen your face before and then you come around again, I'm going to be like, didn't you just take the study? So again, there's some advantages and disadvantages to doing this over the internet. But this is our last slide. So we are done officially with Unit 2. Again, we're moving on now to Unit 3. Unit 3 is all of our statistics. So again, if you haven't taken that statistics readiness check, please make sure you do that you review that mathematical concepts review that I've posted so that you are ready for our next unit. Tomorrow you also have exam 2, so make sure that you get your study going for that as well.